Okay, so in this video we're going to look at answering a past exam paper question. This is an achieved question, okay, and therefore I'm not expecting it to be particularly difficult. First thing I notice is very generously in the question they've told me which distribution I'm working with, but I'm going to talk about how to identify that anyway. So if I read through the question, road service on average there are 3 call-outs per hour, so they've given me the average amount and they give me a time interval, so that tells me that it's a Poisson distribution. Remember, the other conditions for a Poisson were that the events happen at random, and this is about call-outs for changing flat tyres, so that's random, that they are independent, no 2 call-outs are going to be dependent, that they are can't happen simultaneously. You can't get 2 calls at once because you're on the phone to the first call and the second one call's coming in. That one's a little bit iffy. And the last thing is that the number of call-outs, or the average number of call-outs, is proportional to the time interval. So if I've got 3 call-outs per hour, then if I change the size of the interval, and I'm going to have to, then it's got to be proportional. So at the moment, I could say that lambda equals 3 per hour. I'll get to that in a minute. Okay, find the probability there are fewer than 2 call-outs received changing tyres in a given 20 minutes. So I've now got to think about lambda needs to change because lambda is 3 per hour. So therefore, if I've got to make it to 20-minute periods, I've got to take my 60 minutes and divide it by 3 to get 20 minutes. So I'm going to do my lambda divided by 3, which is 1 per 20 minutes. Okay, so I've done my conversion for my lambda. The other thing I need to be clear about is that my probability is x. Now, fewer than 2, does that include 2? Fewer than 2 does not include 2, so it's less than 2, which means that I'm going to be working out, because my calculator needs it to be that way, that x is less than or equal to 1. Okay, remember binomial and Poisson distributions are discrete. So now I can fire up my calculator. If it's a less than or equal to, I need to use Poisson CDF. So I'm going to turn my calculator on. I need to use second function variables to get to the binomial and Poisson. I'm going to scroll up. So it's a Poisson CDF. And then my variable, my conditions that I put into my Poisson CDF is that there's 1, that's my lambda, and then my x value is also 1 because I want to be less than or equal to 1. So I'm going to write down that my working was Poisson CDF. I'm going to open the bracket and I'm going to give myself the values there, and my answer was 0.7 358 7358, and that was to 4DP. Okay, and that's us done.